Section 2.1 is on scattergrams and graphing linear equations. In the first part, we're looking at the Cartesian graphing system. The Cartesian coordinate system, it's named after René Descartes, is a grid of two axes, the x-axis and the y-axis. And they're like number lines, but one of them is horizontal and the other one's vertical. Okay. When we graph on this Cartesian grid, we use ordered pairs that are ordered x, y. So the horizontal axis is going to be the x-axis, and the vertical axis is going to be the y-axis. So we're plotting in 2 dimensions, treating this as 2 perpendicular number lines. So I'm going to rewrite that in pen right here. We have our x-axis and our y-axis. Okay. Now, because these 2 axes kind of partition our page into 4 different segments, we call those quadrants. We're going to number them as quadrant 1. Quadrant 2, we'll just shorten it to Q2. Usually we actually use Roman numerals for these instead of Arabic numerals. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. The shape of 1, 2, 3, 4 forms the C, which is short for the Cartesian coordinate system, but that's actually not why it forms that shape. It's just easy to remember it that way. The reason it forms this shape is that you would put 0 in the middle for both of these. So 0 is called the origin. And it's the point where both x and y are 0. And if you count a number line up 1, 2, 3, be down -1, -2, -3, etc. And then up would be positive 1, 2, 3, and down would be -1, -2, -3, etc. So quadrant 1 got to be number 1. I mean, if you're reading, you'd think 1 might be over here. It got to be 1 because you have positives on this side, +3, versus over here you'd have negative x values and positive y values. Quadrant 1 has both x and y positive. That's why it's number 1. Okay. All right, now we're just going to plot a few ordered pairs here in example 1. Ordered pairs are always in the form x, y, so you always do your horizontal axis first, then your vertical. First I'm going to label these axes as x, y. So I always count my x value horizontally, then my y value vertically before I draw my ordered pair. Sometimes we like to label these here as well, so I can label these x and y. So the x value is 2. So over 2 in the x direction, don't draw a dot yet, then go up 6 in the y direction. And then we're going to label that one point A. Point B is 6, 2, so that's 6 in the x direction, 2 in the y direction. So we can see why they're called ordered pairs. 2, 6, and 6, 2 are not the same point. They're in very different places. So the number that you go horizontally versus vertically matters which one is which. Then I have 4, -2. It's a +4 in the x direction, then down 2 in the y direction. Okay, -1, 3. It's -1 in the x direction, so back 1, then up 3 in the y direction. So it's point D. E, -5, -2. That's back and down. Both coordinates negative. F is 0, 3. So the x coordinate is 0. It stays in the center and just goes up 3. So F is going to be right next to D. G, 4, 0. You go over 4, then you don't go up or down any, so you stay right there on the x-axis. And then -1, -2.5. So -1 on x, -2.5 on y. That's H. The last one just illustrates that these don't need to be integer values. Of course, it's a lot easier to graph them if they are, because then you can find corners of boxes to plot your points. If it's not integer, you have to kind of approximate where the dots should be. Definition. We say that an ordered pair A comma B is a solution. I guess I should put an A there. Is a solution of an equation if the equation becomes true when A is substituted for X and B is substituted for Y. You have your X value and your Y value. The solution set of an equation is a set of all solutions to the equation. Okay, looks like my mouse got screen capped there. That's okay. So this should just say X. Looks like I got a little mouse screen cap going on. So I've got X and Y, and I want to first just find 5 ordered pair solutions to this equation so I can graph the equation. So I just get to pick values for X. I can choose anything I want. It probably makes sense to choose a few positives, a few negatives, and maybe 0. So I'll start with 0. And I'm going to plug those values in for X and calculate the Y value. 0 is the easiest one to plug in because negative 2 times 0 is 0, plus 4 is 4. Okay. Then I'll plug in, say, 1. Negative 2 times 1. I can do some work off to the side here. Negative 2 times 1 plus 4. That's negative 2 plus 4 is 2. Okay. I can show the first one if that helps too. We got our 4 there. Okay. If I plug in 2, okay, so this is negative 2 times 2 plus 4. Negative 2 times 2 is 4. Negative 4 plus 4 is 0. And I could keep going on that. I'm going to plug in a couple negative ones as well. So we'll have negative 1, say, negative 2 times negative 1 plus 4. That's actually going to make that positive 2 plus 4 is 6. And if I plug in negative 2 times negative 2 plus 4, that's positive 4 plus 4 is 8. Okay, so let's draw all of these dots. 0, 4, that's the first ordered pair. 1, 2, so that's 1 on X, 2 on Y. 2, 0, 2 on X, 0 on Y. Negative 1, that's left on X, 6. Wait, hold on, that was 5. That's 6. My bad. Apologize on that. So I need some white out in my office. All right, and then negative 2, 8. So negative 1, 2, 6, 7, 8. All right. Now we're going to need a ruler or some kind of straight edge, and I can see that these form a pattern, and the pattern they form is actually the full graph of this equation. So I'm going to connect these. So if I want to graph an equation like this, the graph of the equation is a line, and I connect the points to form the line. Okay. So I could have made many, many more points for X, but once I have, in this case I did 5, the minimum you could probably do is 3, but we like to have a few extra points just to make sure we can connect this all the way through. Okay. So the full line that we drew, not just those particular 5 points, because there are more and more points. Like I can see some down here. There's another one, and there's another one, and so on. I can see some more points down there. Okay. Now in the next one, we're going to choose some values for either X or Y. I happened to choose just X's up here because Y was solved for, so it was convenient to plug values right in for X. Here I don't have a variable solved for, so I'll plug in some values for X and I'll plug in some values for Y. So we'll try both and see where we get. Okay. You don't always have one variable solved for. So let's start plugging in some values for X first. I might try 0. Okay. So if I plug in 0, first of all I want to make a note of what I just plugged in. I plugged in 0 for X. That gives me negative 3y equals negative 3. There's a little bit more solving to do here. So I'm going to divide that negative 3 off. I can ignore the 2 times 0 is 0 piece, right? 2 times 0 is 0. If I rewrite that, that's 0. So I can divide by negative 3 and get y equals positive 1. Okay. If I plug in another value for X, let's say we plug in 1 for X. I might have 2 times 1 minus 3 times y minus 3. 2 times 1 is 2, so I'll subtract 2 from both sides. I forgot the equal sign, sorry about that. That gives me negative 3y equals negative 5. So y equals 5/3. That's not a very convenient point to graph. It won't give us an exact value, but that's what we've got for our y value. See if we can find some nicer points. It's going to turn out, if you have two coefficients like this, that you may have to skip around. Like 0 worked, 1 didn't. 2 probably does not, but if I try 3, I bet it will, because of the 3's that I see here in y and in the answer. So I'll try one more value for x, and we'll plug in some for y as well. So if I try 3 for x, then I have 2 times 3 minus 3y equals negative 3. So that's 6 minus 3y equals negative 3. So if I subtract 6, that's negative 3y equals negative 9. Divide by negative 3, divide by negative 3. That's y equals 3. Now, there's a lot to be said if you're going to be graphing an equation this way to rearranging this equation and not having it with the x's and y's on the same side. We'll work on that later. There are definitely some advantages for having your y equals, having your y by itself. So we can still work with it. It just takes us a little more time if we haven't gone that extra mile. So that's one of the reasons that we do like to do that in some of the subsequent sections. All right, just to show that we can plug in a variable for either value, let's plug in some y's. I'm going to start with 0 for y. So if I start with 0 for y, I could have 2 times x minus 3 times 0 equals negative 3. That's just 2x equals negative 3, and I can divide off the 2 to get x equals negative 3 halves. Okay. Not super convenient to graph, but we can do it. And then one more value for y. Let's try 1. Okay. Actually, I don't want to choose 1. I just noticed that. And that's because I already have a 1 in the y column here. If I do that, I will get the same thing back over. I don't mind. So let's try it just in case, just to verify that. Pretend I hadn't noticed that. So 2 times x minus 3 times 1 equals negative 3. If I add this 3 to both sides, that would give me 2x equals negative 3 plus 3 is 0. Divide by 2, I will get x equals 0. So if you're choosing a new number for y, choose one that wasn't already solved for. Maybe I could have chosen 2, I'm not sure. All right, so I'm going to go with the points I have. I'm going to graph them. I'm only really going to have 4 since one of them was a duplicate. So first of all, 0, 1. 0 on x, up 1 on y. 1, 5/3. Now, even if you haven't written down the decimal for 5/3, you might want to think about it, because 5/3 is 1 and 2/3, so 1.67, so you know about where to graph that. So that would be 1, comma 1, and all the way to 2, 1 and 2/3. Okay. 3, 3. So 1, 2, 3, 1, 2, 3. Negative 3 halves. The same thing on this one is you want to probably think about it in decimal. That's negative 1.5. It's negative 1.50. And then 0, 1 we already had. So if I connect these, remember that the dots themselves aren't the graph. I'm looking for the line that connects them. The graph of the equation is the full line. Now, this type of equation is a line, so I'm going to put or curve just to generalize it. Eventually, we'll be looking at curves that aren't straight lines, but it's not dots. That's what I want to emphasize here. The graph of an equation is not just dots, it's the full connected piece. It has to be connected. I'll emphasize that as well.